I got 28.
Okay. Okay, the homework is the blue packet. Like the previous packet, I have a few extra examples that we'll work together in class, because the extra examples don't have answers in the back. So flip the page to the first extra example. It's labeled as extra example 2E. You already know how to solve this problem, so it's just a little extra practice. So go do that one. Go. Stop me if you have a question. Flip the page over. It's extra example 2E. So work that problem. Stop me if you'd like to ask something as I walk by. Go, go, go. So this is a question that's just like several of the homework questions. So it's not new, it's just a repeat of what was in the homework. We'll always work it out anyway.
And is that true with...
You do the next one too, Abby?
Well, the remarks said.
You don't have that. Wait, is that what you did? Okay, awesome. Oh, she loves the answer though?
If you're having trouble with this, listen close. Listen close. Okay. This is an example where the computations are extremely simple. It's really computations that any third grade student can do, because it's just, I guess they don't know division yet, but say fifth grade. But what's crucial is you make sense of the computations. If you make sense of the computations, then they're easy to remember. So if anything I say doesn't click, just ask me to say it again. Just keep me talking until it really clicks for you. They give us this table. The table shows different values of water temperature. They ask us for an approximation of W prime of 7. W prime of 7 means the instantaneous rate at which the water temperature will be changing on day 7. You need me to say that again? Just wait. Okay. So W prime of 7 is the instantaneous rate at which the water temperature is changing on day 7. It's how fast the water temperature changes right on that day. Because we notice that the water temperature is different from day to day. So we want to know how fast is the temperature changing on day 7. So we're interested in this spot on the chart, but there is no day 7 listed. That really has nothing to do with the problem. I don't care about that at all. What I notice is, from a table, I have no way of finding this instantaneous rate of change. I can't do it. But I could say that from day 6 to day 9, the temperature dropped by 4. So I'd say the temperature ended up being 24 degrees. The temperature was 28. So let's see. That's a drop of 4 degrees Celsius. Okay, that's not a rate. Rate is always a ratio. So I must compare that drop in temperature with how much time elapsed during that drop. So that's a 3-day time span. So now I have the average rate at which the temperature is changing between day 6 and day 9. It's an average rate because it takes place over a time period. But that's what I use as my approximation for the instantaneous rate. I always approximate an instantaneous rate by finding an average rate. You need me to say it again, just wave at me?
I guess that makes sense. I just haven't been doing it in degrees Celsius over days or time. That is correct. And say we were doing a Riemann sum or something like that, would our units just be Celsius?
It would all depend on what the Riemann sum was calculated. So that will be different.
Okay.
So there's not a straight answer for that one. Here's all eyes on the board, everybody. The units are worth a lot of points on the AP test. The best way to verify that you're getting the right units is to just look at your numbers one by one. So just this saying out loud really will help. So just say out loud, what are the units of 24? Celsius. What are the units of 28? Celsius. So the numerator has units of Celsius. What are the units of 9? So the units are degrees Celsius per day. It's that simple. Just look at the numbers, then the units are easy. 2 for Maya. Unplug for me, Maya just distracts me. Questions here? Anything? Okay, on the AP test, this will be worth 2 points. 1 point for showing your computations, 1 point for the answer matting.
Okay, normally, I don't know, does it matter if you do like, when you do W prime of 7? Does it matter if you do like just equal signs or like the ones that are like the squiggly ones? Does it matter because this is one approximation?
2 points. Because they said find an approximation, I should have said squiggly.
Okay.
I don't think they'll deduct a
Okay.
point for that.
Thank
Good
you.
question. Rachel?
Just kind of a general question. Do you always need to get it all the way down to -4/3? Because I remember on one problem they left it as W prime of whatever minus W prime of whatever. So
Yeah, you can stop here. It's fine.
okay.
You don't have to go further. 2 points. Read me the name. Just read it. Trey, raise your hand. Anybody else? Okay, next one. This one also does not require any additional instruction from me. It's just like the homework from last night. So go do the next extra example, 2F. Go. Don't get it over yet. Oh, you already did it.
How am I supposed to like notations all that? Like I know that's wrong. Like what like get rid of it just in my head or whatever.
So right here, you would have lost a point. This is calculated doing this, but it's 1/12 times. So you need to have a 1/12 here.
I would when I read that.
Otherwise, they're not equal, because this is 1/12 multiplied by the integral is 1/12 multiplied by the integral.
So this problem is where it's average. I can do that.
You have to, otherwise, if you declare something to be equal that isn't, you're going to lose a point for lying.
So then can I just like,
So this is 52.
yeah, can I just get rid of that middle letter?
This doesn't make any sense.
Yeah, I know, it makes no sense.
Yeah, you can't write equal unless it's equal. the
moving
scratch
the
word.
6 over.
Yeah, the scratch word just do it over here.
Okay.
Yeah, don't write.
I can
into
just
the-
have that.
Yeah, that's fine. You can just stop it. Just say degree Celsius 15 degrees.
Oh, okay. Yeah, I did the same thing.
Okay.
You started? Oh, 3 to 15. Yeah, no, I did the same thing.
Oh my gosh.
And I was like, oh yeah.
That's exactly what I'm saying.
No.
But then I need to divide by.
Are you just starting with your one node?
We can get a picture.
The 6 over 12. Because that's.
Stretch.
Whatever an average.
Oh, it's because you included zero.
This is
But yeah, it just
But this makes sense later.
I think you will have to split by 6 because the interval is
Like, how like, we might like.
Oh, yeah. Yeah. And then I got 3.
Yes, I think that should be right.
Okay.
But then the first one is negative separate
Or what? For the first one, I just figured and then find the average. You guys are all listening here, so.
Is it definitely is there?
I don't get This is number one.
We should
Let's
do
go on to
this
the
again
next one.
sometime. It's been marvelous.
Now this has just.
It's weird.
There's somebody's imitation on YouTube. That's clearly. I have no.
Mr. Smith, when you're doing the average and you have to do that fraction in front, if it's like a 0, do I have to write 15 minus 0? Can I just
No.
write
You don't have to, you can just write 1 over 15, is that what you meant?
Yeah.
Okay. You don't have to write average of W of T. You do have to write this. Look at your paper, look at the board, raise your hand if you have this written on your paper. Show your hand. 2 points. Anyone have a question? Please. 12 is fine. Okay. 2 points for Lindsay. Anyone else? Please.
Okay, so
Yeah,
one of the
that's
examples yesterday, I don't think you wrote the, last time,
the 3 and the 15 on the integral, do we have to?
Here you do have to. If I didn't yesterday, that was my mistake.
Okay.
Yeah, you have to say, all eyes on me. Okay, like most things in this class, if you can make sense of the idea, memorizing it becomes literally 10 times easier. So the reason this is an average, somebody asked that as I was walking around. W of T is the water temperature, okay? This table shows different water temperatures. To find the average water temperature, we need to take several different values of W and add them up. Fair? Nod if that makes sense. Okay. The 3 and the 15 are required because they tell you, go find the water temperatures that are between 3 and 15, because those are the average, those are the temperatures we want to average. So W of T is how we find the water temperatures. The big S is how we add them up. The dt actually comes out and combines with this, and you get a fraction that is equivalent to the number of values that you're adding up. That's how we get them added up divided by how many. So that's why this is an average of W. You need me to talk more about that. Cool. Oh, please.
Oh, sorry. So on number 18 on that last packet, it had like 1/8 is the fraction, but all the like D of T's, it was like 1 and 5 and like 4, and so like none of those are the same. And so can you just do everything on that right side and then just times it all by 1/8 if you can't pull out the same time period in between each like subinterval? Because it was 1, 4,
Gotcha. Yeah.
1, 2.
You are correct. So don't, like if I were working this problem, I would have said, let's see, the average of the temperature is 1 over doing the average temperature of the wire over the whole span. So it's 1 over 8 minus 0. So what you're saying is correct. It's not really easy to pull the dx out because the dx is different. So it would take me a little longer to sit down and explain why this still is a valid computation of the average. So we won't do it in class, but you're right. Don't.
But you would just times them.
You just do it.
And then times it all by 1/8.
So I would have written 1/8 here, parenthesis. They want me to do a trapezoidal sum with the 4 subintervals. So we got 1, 2, 3, 4. So then I'd say 1/2, 100 plus 93. Times 1, like that.
Okay.
Is that what you meant?
Yep.
2 points. Anybody else have a question here? Really good question, Brennan. Is everybody good to hear? Then I'm supposed to do this with a midpoint Riemann sum with subintervals equaling 6 days. So this becomes 1 over 12. A big warning, as I walked around the room, a lot of people put 1 over 12 here. They forgot to write 1 over 12 here. You'll lose a point for that. These are only equal if the 1 over 12 is in both places. So don't forget the 1 over 12. Midpoint sum. So the middle of the first subinterval would be W's value is 28. That gets multiplied by 6. 22 gets multiplied by 6. Like that. We're finding the average temperature of the water, therefore the units are degrees Celsius. Question? Please.
Why'd you put the squiggly equals in
Because a Riemann sum is an approximation of an integral. The average value of the water temperature is exactly this integral, but the integral is an approximation. Don't stress too much on the squiggly versus equal. If you mix it up like I do regularly, they won't deduct the points. Ellie, 2
Would
points.
you lose points for bringing up 6 right away, not like writing it?
No, they're okay if you pull it out. I like to leave it because then I can see quickly that you understand the midpoint sum idea.
Okay.
2 points. Anyone else? Okay, I want to do the units again, so say them out loud with me, please. Like, it needs to make sense to you. If it doesn't, just wave at me so I can help you make sense of it. What are the units of 28? Say it.
Celsius.
So Celsius for 28. What are the units for 6?
Days.
So you got Celsius times days. Those get added together, you get Celsius times days. But what are the units of the 12?
Days.
So that's where the days divide back out. You end up with just Celsius. Questions?
It also
Please.
says,
Oh, go ahead, Heather.
I was just going to say, it says that find the average temperature in degrees Celsius.
Perfect. They literally tell you the units. It's perfect. 2 points. Ellie?
So, because it doesn't say, like, use indicate the units of measure, would you lose points if you didn't put the units?
Probably not. I'm pretty sure that if they want them, they'll tell you. I always recommend putting them because it's just a good habit. That way, if you kind of didn't notice that they asked for them, you'll still be okay. So, good question.
If you do more steps than that, like another step is where you pull the 6 out, and then the final step's the answer. Do you have to keep writing degrees Celsius on all of the steps?
You want to have the units on the very last one.
Just for sure. Okay.
The units along the way don't really matter. It's the very final. So, 2 points. Anyone else? Next thing. So go to the next extra example, which is extra example 3E. Okay, you want to practice reading the AP test slowly and carefully, stopping at commas and periods. So it says an object moves along the x-axis with initial position x of 0 equals 2, and then there's a period. So someone, raise your hand, I'll call on you. Earn some extra credit for explaining to the class what does that sentence mean. Like, just restate that sentence in your own words. Hadley.
Something is moving along the x-axis and it's starting at like time 0.
Well said. So I've got a line. There's the origin of the line, which is the center. The origin is location 0. I've got a particle sitting over here at position 2. And the particle is at that position when time is 0. That's what the situation is. 2 for Hadley. But you need me to repeat anything? Right.
I'm kind of confused why it's not p of 0. I don't get why the x is placed there.
The x here or this?
Yeah, in the word problem.
Right here. So this symbol, you just need to memorize, simply means the location along the x-axis. That's why there's an x. At time 0. That's all. 2 points. Anyone else? Please.
I know that a lot of the times when we're looking at these, we're not looking at x, y charts, but when it says moving along the x-axis, my brain went to like an x, y. So when I saw that, I pictured x of 0 being y, so then it would be y equals 2. So why is it not that?
So what you're thinking of is, this is the actual particle. It's right here. It just goes back and forth along this line. If I make a graph of the position, the graph of the position would look like this. And this point right here is x of 0 equals 2. So this isn't the actual particle. This is a mathematical graph of the particle's position, where the y values represent where the particle is located and the x values represent time. This is different. This is literally me.
Okay.
Here's my line. I'm standing right here. Does that make?
Yeah. Yeah, I think so.
So both thoughts are valid. Like, this is true, but this is also true. This is how the particle really goes like this.
But that's not its velocity.
No, that's its position.
Okay.
As it moves, it's going to have a velocity, but this is just a picture of where the particle is located.
Isn't that what the XY is? Too?
This one here, it's not.
Okay.
So, hey, everybody, this really is a good question because this mixes people up all the time. The particle is nowhere to be seen in this picture. This is just a mathematical representation of the particle's location. This is the actual particle. You can walk up, you can grab it, you can hold it, you can look at it. You can't do that here.
Okay.
This is just a math chart.
Okay.
This is real life. Does that help a little?
Yeah.
You good here? Okay, please.
How would you know what time it is when you're ordering the particle graph? I guess?
Say it one more time, Isaac.
So how do you know what time it is when a particle does? Do you have to label each time stamp, I guess?
Perfect. In this picture, you have to have a label that says, hey, here's where the particle is at time equals 0. When you're looking at the graph over here, the graph communicates that information more concisely. Like that dot has 2 numbers associated with it. The 2 numbers are 0 and 2. 0 means time, 2 means location. So when I read this chart, I can tell you, here's where the particle really is. This is not the particle. These are just math numbers telling me information about the particle. This is really the particle. You've got to keep that straight. It makes a huge difference. 2 points for Isaac. Anybody else? Cool? Okay, next thing. Question says at time equal 4. So right now we just have information about time equals 0. Oh, they give us the formula for the velocity as well. At time equal 4 is the object speeding up or slowing down. Justify your answer. We get to use our calculator, so we want to get a picture of the velocity. So grab your calculator. You should get that picture. Stop me if you can't get that picture. Go. You should get that picture. Stop me if you can't. Alpha F1 is the fraction. Okay, show me your hands. Who has this on their screen? 2 more. Anyone have a question? Okay, here's something most people have not seen before. Go second quit, back to the main screen. The velocity is in y1. So alpha F4, choose y1. Get to there. Okay, we're trying to find out if the particle is speeding up or slowing down at time equal 4. So I'm going to type parenthesis, time equal 4, close parenthesis, enter.
How do you do that on an Inspire?
So on the Inspire, go to the calculation window, hit the variable key. You should get like F1 or F2, whichever is your velocity. Choose the one that's your velocity.
Wait, sorry, go to the variable?
So you're on the screen that's the calculator, right?
Yeah, I thought it was.
So let me come back there. 1 second. If anybody else has an Inspire, just come back to my side.
So negative just means that it's going down. But when does it go back? When do you know it's so is this going back and still down? Oh wait.
Questions, anybody? Hey. Everybody good? Okay, that's the velocity of the particle at time equal 4. So you need to write that on your paper. So the velocity of the particle at time equal 4 is equal to negative 0.866. Hey, someone, what does that mean? Hands up. Oh, no, come on. This is not new material, just reviewing things we've talked about all year. What does it mean for the velocity to be negative 0.866? Zach?
It's moving backwards at 0.866.
There's no units, so we'll just kind of think meters per second or whatever. So the particle's right, we don't know where it is actually because time is equal to 4. The particle's somewhere, but at that moment the particle's moving to the left. Okay, 2 points for Zach. Question. Awesome. They're asking if the particle is slowing or speeding up. We don't know yet. All we know is the particle is moving left.
Because it's negative.
Say again, Brent.
Because it's negative.
Because the velocity is negative. So you have a flashcard that tells you the positive or negative of the velocity indicates direction of travel.
So then, so the speed was just like the velocity, absolute value of it. So then, do we have to find the absolute value at 2? I mean, at time equals 0. Or is that 2?
There's a better way I'm going to show you this.
Okay.
Other questions here? Please, hey.
Why is it not x of 4 equals a negative 0.66?
So x of 4 means the position of the particle. I don't really know that. I use this formula for velocity. So the velocity formula will tell me the velocity of the object at any time I choose. And so I plugged a 4 into this formula. Is that your question? 2 points. Anyone else? Okay, next thing. Okay, to determine whether the particle is speeding up or slowing down, you need to find the acceleration of the particle. There are other ways to solve this problem, but the way I'm showing you is the fastest, easiest to remember. So we need the acceleration of the particle at time 4. We can use our calculator, so we're going to do this. Math 8. On the Inspire, it's just on the key that has the same thing as the integral. I'll come show you in a second. It's a few more strokes. Okay? The calculator, the 84 will find the derivative of a formula at a point. It's not an exact calculation, it is an approximation, but it's a pretty good approximation. So we put an x right here. We want the derivative of the velocity. The velocity is in y1. And we want that derivative at time equal 4. Wade, can you need me to do it again? So on the 83, you do math 8, y1, comma x, comma 4. Does that work? That didn't work? Drew's work. You good, Elijah? Anybody else? Okay, on your paper, write this down. Remember, it's the written portion of the AP test, so the writing is critical. Write that down. If you don't write them down, you lose points. So, okay, here's the interpretation. At time equal 4, the particle is moving to the left because the velocity is negative. At that exact same moment, the acceleration is also negative. Okay, the acceleration is telling you how the velocity is changing. So, the velocity is already negative. Negative acceleration at that moment means the velocity is going to become more negative. So is the particle going faster to the left or slower to the left? Faster. Its velocity is more negative. So you write down, since V of 4 and A of 4 are both positive, sorry, negative, my bad. That was weird. Are both negative, the particle speeds up. And you make a flashcard that says, if the sign of the velocity and acceleration are the same, the particle speeds up. So you make a flashcard that says, if the signs of the velocity and acceleration are the same, the particle speeds up. They're opposite, the particle slows down. The flashcard is a lot easier to memorize if it makes sense to you, so if anyone needs to talk more about it, just wave and we'll talk.
Just go over why that is.
Talk with me, it'll make it easier. So at time equal 4, Elijah, the velocity is negative, which means what? It's going to the left. Okay, the acceleration is the rate at which velocity changes. So at that exact same moment, the acceleration describes how the velocity will change. So the velocity is going to become more negative because the acceleration is negative. If this number becomes more negative, it will have a velocity which is larger. Well, it's not really larger, but it speeds up. Did that help at all? Yeah. Okay. 2 points, please.
Can you see any of that from the graph on the calculator?
You can. So let me say 2 things. There are multiple ways to solve this problem for sure. This way is the most efficient, quickest, easiest, safest, best. But you can also look at the calculator and say, here's my velocity.
Is that absolute value of it?
Right. So if I do the absolute value, in fact, I can even plot that. I could come here and say, let's do the absolute value of the velocity. Like that. So the blue is the velocity, the red is the speed. And just look at the graph at time equal 4. So go 1, 2, 3, 4. Right here, this is the graph of speed. Is the speed increasing or decreasing?
It's increasing.
So the particle's speeding up.
Okay.
Does that make sense? Perfect. 2 for Rachel. Anyone else? Did you get yours to work?
Yeah.
So you're okay?
I couldn't get it to put f1 as the...
So you had to retype it?
So I just typed the equation.
Let me show you because it's safer to use the f of 1. Every time you retype something, chance you type it wrong, you know what I mean? So do this. Another way is, let me show you the way. I don't know which is better. I want to get clay on the side.
My right hand writing is how it
So that's
How did you see how we got to that number? It's just math.
Any other questions here? Okay, on the AP test, here's how the points are awarded. You would get 1 point for having these two. The second point is for this sentence. Question. Next one. So, extra example, 3F. At time equal 4 is the object moving toward the origin or away from the origin. Justify your answer. Okay, we figured out already that at time equal 4 the particle is moving left. So here's our line. Here's the origin in the middle. We know at time equal 4 the particle is moving left, but we don't know where the particle is at time equal 4. The particle's here at time equal 4 moving left, it'll be going towards the origin. But if the particle is here at time equal 4 and moving left, it will be moving away from the origin. Wave if you'd like me to do that again. Okay, good. So we need to know where is the particle at time equal 4. Please, hey.
Wouldn't you just take the integral of the acceleration?
Of the acceleration,
Velocity.
the velocity. So Hayden is remembering what we did before Christmas. If I integrate velocity from time equals 0 to time equal 4, the value of that integral will compute by what amount does the particle's location change during that time period. So this should look familiar to you from before Christmas. This is known as the fundamental theorem of calculus. We talked about that before Christmas. If we rearrange the fundamental theorem, we can say the position at time equal 4 is equal to the position at time 0 plus by what amount does the position change during the next 4 seconds. And we can compute the position at time equal 4. 2 points for Hayden. Hands if you'd like to talk more about this. No concept is tested more heavily on the AP test than this concept, the fundamental theorem. About 1/3 of all the points available to you come from knowing how to do this. Okay, cool. We good there? So we want to find x of 4. We know x of 0 is 2. We can use our calculator to find that integral. So math 9, 0 to 4, integrate the velocity. We got it. Question.
Why do you add that?
So the integral never computes a position. The integral computes a change in position. So the integral's value is 1.432. That means that at time equals 0, the particle is located somewhere. The earlier description said that at time equals 0, the particle is at location 2. So 1.432 means from time 0 to time 4, the particle's position will be different by that amount.
Okay, so it is at that position.
So I was at 2. The change in my position is the 1.432. Therefore, my new position is 3.432. Did that answer your question, Brendan?
Yeah.
Good point. Anyone else want to talk? Please.
Can we go over how, like, we looked at the problem and then remember to do the fundamental theorem with the calculus?
Gotcha. So I read the question, so the description is the same, so I skipped that. At time equal 4, is the object moving toward or away from the origin? So I picture my line, that's my visual image of the object. I'm like, the particle's got to be somewhere at time equal 4. I don't know where it is. If the particle had been over here at time equal 4, I know the velocity is negative, because we just did that a minute ago. We figured out that the velocity at time 4 is negative 0.866. So I'm thinking, okay, if the particle's here with a negative velocity, the particle will be moving away from the origin. But if the particle's over here at time equal 4 with negative velocity, the particle will be moving toward the origin. That's what prompted me to say, I need to find the location of the particle. And from there, my next domino was, oh yeah, I remember the fundamental theorem. And the rearranged version of the fundamental theorem can find the position of the particle. It's also related to what you put in your notes, last time, this chart. I'm going to use integration to find a location of a particle.
So the first three are all the fundamental theorems?
These three are all the fundamental, well, this one's not technically. The first two are the fundamental theorem for sure. It's kind of a variation of the fundamental theorem. So yes, all three of these are the fundamental theorems. Perfect.
So it's the fundamental theorem, I guess, is just saying like the integral in this domain is equal to like that minus that, like the domains.
The fundamental theorem, when we talked about it before Christmas, we said this. It's Danica's chart. If this column is velocity and this column is position, if we integrate the velocity, we end up finding not the position, but we find a change in position. How much the position changes during that time?
Because it finds that area.
The area of the velocity is the change in position. If you integrate acceleration, you find the change in velocity. That's the fundamental theorem. There you go. Cool back here. So now we know that the particle is sitting right here, and at that moment the particle has a negative velocity, hence the particle is moving towards the origin. So to get full credit on this problem, you must show this work so the grader can see how you figured out the position. You don't have to write the velocity again because you already did it in the earlier part. Then you need a sentence that says, since, let's see, position at time 4 is positive, and velocity at time 4 is negative, particle is moving towards the origin. Good questions. Other comments, questions, anything? You have to have this work or you will lose points. You have to show how you are finding the position. You have to have the sentence, you don't get the point either, because it says justify your answer. So. Mikhail, please.
And for it to be moving away from the origin, would they both have to have the same sign?
Perfect. So the flashcard should say something like, if the position and velocity have the same sign, particles moving away from the origin. 2 points for Mikhail. Anyone else? Next thing. So go to the next extra example. 3G. This is not a new idea. You should be able to do this without me helping you at all. Go. Do extra example 3G. You should be able to do it without any help. It's just review. Who has that written on your paper? Look up there. You don't need to have the words, but who has this here? Who has that written down? 2 points. Okay. Questions? Anything? Awesome. Next one. So extra example 3H. Before Christmas, you made a flashcard. I think you made it earlier in the year as well. It says the speed is equal to the absolute value of the velocity. So average speed is just the integral so 1 over 4 subtract 0. Integrate from 0 to 4, absolute value of the velocity. On your calculator, that can be done with, let's see, fraction first. 1 over 4. Integral 0 to 4. Absolute value. There are different ways to get absolute value. My favorite way is to go to the catalog. The catalog is a list of all the functions. So that's keyed down here 0. So go second, catalog. And because absolute value is spelled AB, it's the first one on the list. There are other ways. That to me is the fastest. You would need me to repeat anything? Just wave at me.
On an A3, is it just the ABS?
Huh? Anyone else? Next one. So go to extra example 3I. And you should be able to solve this on your own. We've already talked about how to do it, so see if you can do it yourself. If not, stop me and I'll help. So do extra example 3I. No, if you integrate.
That would be fine with velocity, because so like it has to be velocity for you to be able to find the position using this.
Correct.
If you use the acceleration, it would just be like velocity and all that.
Correct.
And then if it was just like position, would that be anything?
Nothing that we talk about.
That's messed up.
I heard you on the first day, and then the next day she
2 minus 2. Yeah. It's hard because like, it's a lot of
Did you do 3i? You got the same thing. So at time 3 and your time 2. Lost 0. And he goes to that, he stays there for a second. So he stops there. But then it would have to go. Then it would be so then at time 0, get 2. It would have to go to there at time 2. Then over here at time 3, and back there.
Yeah, really you don't know. Unless you want to figure out.
Wait, Eddie, it actually wouldn't even be bad. You just do 0 to 3, so then you do would just be would be watch this. Yep, this is what it's actually.
DT is 0.16. Excuse me, sir.
Look, I just put my article. I just
Yes, you good. All up. That's what I do.
it was like
Oh wait, you're genius.
And now she's like
I may not be able to do pictures. It was so bad. Have a performance. Yes, I demo.
Okay, to get the points, you have to write this on your paper. So hands up if you have this written on your paper. Look at it. If you don't write it, you lose points on the next test. The next test is written. The pop. So, who has this? Show me. 2 points. Okay. Then you do the computation using your calculator. So this was 2. You need to go do the integral. Zero to 2. Velocity.
Wait, did I do the right answer?
Questions from anyone?
Can I ask what your original equation was? Because I had the integral equals x of 2 minus x of 0. Is that wrong?
That's right.
How does it bring the... I'm confused on the algebra. But
So you had this. Is that correct? So all we're going to do is we're going to add x of 0 to this side. Okay.
It's the same exact thing.
Just make it sure.
Yes.
Questions from anyone? Okay, the homework is the rest of the blue packet. So good work. Thank you.
Jim was texting me.